Greetings of the day, dear students. In this video we are going to discuss about the fuse element and what are its characteristics of a fuse element, and what are the materials used to make the fuse, and what are the different types of fuses we are having. All those things we are going to discuss in this video. Now basically the fuse element is designed to carry a particular rated value of current under normal condition. As long as the conditions are normal, right, then it is going to carry the rated value of current. But if any abnormal conditions like short circuit, or if any overload occurs, or if any fault has occurred, then the current flowing through the circuit will be above its rated value. Now the equipment is to be protected from the high magnitudes of current. Then this fuse gets operated in such a way that it is going to isolate the equipment from the supply. It is going to isolate the equipment from the supply, right? How it happens? Because of the high magnitude of current flowing through the fuse wire, right? Now the fuse element gets heated up and it is going to melt and it is going to break the circuit. Because of the high flow of current, the fuse element gets heated up, and because of the heat developed across the fuse element, it is going to melt and it is going to break the circuit. So it is going to disconnect the load from the supply. In such a way it gets operated. So obviously for example, if you are having a source like this, and if you are having a load equipment like this, and if this load is to be protected, if any abnormal condition has arisen, then in series, in between the source and the load, we will insert a fuse element. For example, here if this load is going to carry or is going to withstand up to some 5 amperes, then you will select a fuse element of capacity 5 amperes. Due to any abnormal condition, if the current is going to be more than 5 amperes, then this fuse element will melt and it is going to get open circuited. It is going to get open circuited, right? So here now the fuse is a short piece of metal which will be inserted in series to the circuit, now which will get melted because of the excessive current flow, right? Now as long as the condition the circuit is under normal operating condition, it is going to carry the full load current, right? Now what could be the element with which the fuse will be made up of? Most of the times it will be either tin or lead or copper, because these elements should have some particular characteristics. What are those? The fuse element should have low melting point. Example, tin and lead is going to have the low melting point, and it should have high conductivity. Example, like copper, and it should be free from deterioration due to oxidation. Example, silver, right? And it should be cheaply available, or it should be of low cost material. Example, some tin and copper. So these are the desirable characteristics of a fuse element. So what are those? It should have a low melting point, it should have high conductivity, it should be free from deterioration due to oxidation, and it should be low cost. It should be low cost, right? So these are the desirable characteristics while selecting the fuse element. Now coming to the materials, most of the times it will be of either tin, lead or silver, which is going to have the low melting points, and of course the copper or iron will be dangerous to use them as a fuse element. But if the same copper, if it is of thin wire, it can be used as a fuse wire. It can be used as a fuse element. But a thick copper wire, will be dangerous to be used as a fuse element, right? Yeah. Now coming to the different types of fuses, we are having the rewirable KitKat fuse, and we are having HRC, high rupturing capacity cartridge fuse. These are the two types of fuses we are having. One is the rewirable KitKat fuse and another one is the HRC cartridge fuse. HRC cartridge fuse. Coming to the rewirable KitKat fuse, here this is the figure you can observe. This is the rewirable KitKat fuse, right? Now this rewirable fuse will be used for the low values of fault current. If the fault current magnitude is very low, if it is to be interrupted, then you can go for a KitKat fuse, right? And this fuse is going to be simple in construction and it is also cheap, and it is going to be available up to a current rating of 200 amperes, up to the current rating of 200 amperes. Now one drawback with this KitKat fuse is their performance will be degrading with respect to the time. For a prolonged use of this fuse element, right, for a long period of operation, its performance is going to get deteriorated. Its performance is going to get deteriorated, right? So that is the drawback. This is the rewirable KitKat fuse, and also we are having the high rupturing capacity fuse, HRC fuse or cartridge fuse. This is the HRC fuse or cartridge fuse. We can observe we are having a brass end plate, and this is the fuse link contact. This is the outer element and this is the fuse element, and we are having some filling powder like this. This is the cross section of a HRC cartridge fuse, right? Now coming to its it is going to consist of a resisting ceramic body having metal end caps to which a silver current carrying element will be welded. It is going to have a silver current carrying element which will be welded, right? Yeah. Now the space within the body surrounding the elements is completely packed with the filling powder. Now the filling material may be a chalk, plaster of Paris, quartz or marble dust, and those are going to act as a arc quenching or cooling medium. As and when there is any abnormal condition like fault or overload or short circuit condition, because of the high magnitude of current, there will be the chances of establishing of the arc, and in order to quench or extinguish that arc, this material or the filling material will be useful to quench the arc or to extinguish the arc, or some flash we used to observe during the abnormal condition. As long as the circuit is getting operated under normal condition, it is going to carry the rated current. It is going to carry the rated current, right? Now here, therefore, it is going to carry the normal current without any overheating. As long as the circuit is under normal condition, without any fault or without any overload condition or without any short circuit condition, the fuse element will not get heated up. But if there is any high rise in the magnitude of current, the fuse element gets heated up and it is going to melt, right? That is the operation. Now the heat produced in the process vaporizes the melted silver element. Now the chemical reaction between the silver vapor and the filling powder, where we have discussed the filling powder may be a chalk or plaster of Paris or quartz or marble dust, right? In the formation of the high resistance substance will help in extinguishing the arc. That powder will help to extinguish the arc. So this is how high rupture high HRC fuse gets operated. This is the diagram of a HRC fuse, right? So the fuse element will be always inserted in series. Those are the key points. It is going to protect the equipment from abnormal conditions like short circuits or overload or any fault. Once the fuse element melts and breaks the circuit, again we have to attend manually to establish the connection. Again the fuse wire is to be wound, right? And again we have to replace that element, fuse element. So that is the one drawback. It cannot, once it has break the circuit, it cannot automatically make the circuit. It cannot automatically make the circuit. That is the drawback. But the advantage is it is simple in operation. It is simple in operation. It is cheaply available. Right? Those are the advantages we are having. Right? Thank you.